As we begin pathfinding, remember that we're essentially performing a graph search, traversing a bunch of connected objects. In a few lessons, our graph view will soon resemble this. I have color-coded the various node views so you can see the process of pathfinding in action. I can step through the process more slowly so you can see more easily what's happening. Our first step is to identify a starting and ending node. In my graph view, the green square is the start node and the red square is the goal node. In this first pathfinding algorithm, called breadth first search, we start at one node and then begin exploring its neighboring nodes. As we explore each node, we check to see if we've reached our goal yet. Nodes that have already been visited turn gray. We've checked them and they aren't the goal node, but we store them in a list for safekeeping. We'll use them later to generate the path. Nodes that are up next to check are stored in a queue, and those are the squares that you see marked in magenta. In keeping with our analogy of exploration, we're going to call these the frontier nodes since they represent the border or edge of the explored world. As we check each node in the frontier queue, we add those into our list of already explored nodes, and then we continue finding new neighboring nodes and expanding the frontier. This cycle repeats until we finally hit the goal node. At that point, we can stop and then trace our path back to the beginning. And if you want to see how many iterations have passed as we explore the various nodes, you can see that here. Remember that each node has a breadcrumb back to the previous node. Those are those arrows that you see here. And we can create a path by following our trail of breadcrumbs, which is this set of nodes colored in cyan. So take a while and familiarize yourself with the terminology used in our scripts. Our maze is stripped down with most of the nodes open, and there are just a few obstructed or blocked nodes. So we have our start node, goal node, frontier nodes, explore nodes, and finally when we're complete, we have our path nodes. I've colored the nodes to make it easier to understand what's going on. When your final Pathfinder is complete, of course, we won't have any of these nodes visualized at all. We will just return a path through all the obstacles, and your game manager can do what it wants with that. These color diagnostics, however, are really helpful to understanding the pathfinding process as we learn it for the first time. So to make it easier to color the nodes, let's alter a few of the existing scripts before we make our Pathfinder class. In the graph class, let's expose the map data's dimensions so they're a little bit easier to get to. We could drill down into the graph class and get the length of the nodes array, but that's a pain to do if we have to do that every time. Let's make a public property for the width and the height, and these are just public versions of the mWidth and mHeight. I'm only using the get accessor, making them read only. In the graph view, I probably should have done this before, but it would be helpful to have a 2D array of node views so we can identify the node views and then color them appropriately. Let's add a public 2D array, node views. In the init method, let's initialize our array to the graph's public width and height. See, those are handy already. And then I use the original nodes X index and Y index to add the node view to the array as I create each node view in the loop. Node views n X index, n Y index equals node view. This way I always know how to find a node's corresponding node view. We just peek into the node views array and use the X and Y index. And I'm actually going to use that right now. One more thing I can add here is a method to color a whole bunch of node views all at one time. Currently, we need to select each individual node view and invoke color node on each one by one. Let's create a public method, color nodes, that returns nothing. We pass in a list of nodes and a color that we want to recolor our node views. For each node n in nodes, if the node is valid and not equal to null, let's find the corresponding node view. And again, I'll just use the nodes X index and Y index and then look in the node views array. If the node view we find there is not null, then let's invoke color node, passing in that same color. And this will be useful when I have to color a whole bunch of different node views all at once, so you can better understand the pathfinding process. All right, so that should be enough to get us started with the Pathfinder class, and that's coming up in the next lesson.